Hello everyone. In this video we will be learning about what is correlation, its various types and different ways of representing it, and also different measures which are used for measuring correlation between two variables. So what is correlation? So before we learn what is correlation, let us see what is univariate and bivariate distributions. In the previous videos we have seen frequency distribution of variables. So there those frequency distributions are actually univariate frequency distribution. So what do you mean by univariate frequency distribution is, here we will have single variable. In all the previous problems that we have seen in previous videos, we had only one variable, usually we take it as x, and for those x values we will write the frequencies. So that was called as the frequency distribution table, also called as univariate frequency distribution. Here in correlation we will study the relation between two variables, and so we will be having bivariate frequency distribution. Means we will have two variables and frequency distribution of these two variables will be given, and we will be analyzing these two variables to find out how they are related. So here we will have two variables and we will take them as x and y. Now let us see what are the situations that comes under this bivariate frequency distribution. Say if I have to do a study about how change in one variable affects the other one. Say for example, if I have to find out the relation between marketing costs and profits. Marketing cost and profit. So if I spend more on marketing, that will enable me to reach more customers or more clients, and that will increase the sales, which will in turn increase the profits, right? So marketing costs and profits are related. If I spend more, I can earn more, and if I spend more on marketing, I would be able to get more profits. If I spend less, I'll be getting less profits, right? So that is about marketing cost and profit. Here these are the measurable variables. I can measure how much money I'm spending on marketing cost, which I can take it as x, and that will affect profit. And this is one of the examples. I can say price and demand of an item, price and demand of a product. Now if the price increases, demand will reduce. Say we want to buy gold. If the price increases too much, then the demand for gold will reduce because people will wait for it to reduce further, right? If price reduces suddenly, all of a sudden everybody will go and buy it, so demand will increase. So here price and demand, they are inversely varying. So that is, if one increases, the other one decreases. So here also these two are related. If I take a variable such that height of a person and rainfall of that city, how much rainfall is happening in that city. Now these two are absolutely not related. It might sound very absurd, but statistics will be used even for such type of research as well. So basically we are finding whether two variables are related or not, and by to what extent they are related. These are certain examples where we analyze values of two different variables. Now coming to the definition of correlation. So what is correlation? Correlation or correlation analysis, it is a study of relationship between two variables. This is not a typical textbookish definition. I am just giving the meaning of it. So correlation is the study of relationship between two variables. Now when we take two variables, we will find out whether they are related or not. If they are related, how they are related, and to what extent they are related. So that is what we are going to learn in this video. So here we have types of relation, types of correlation. The first one is positive correlation. Here, if two variables deviate in the same direction, then we say that there is a positive correlation. Deviate in the same direction. So what does this mean? If one variable increases, other variable will also increase. If one variable decreases, other variable will also decrease. So that is called as positive correlation. So example is marketing cost and advertising cost and the revenue, advertising cost and sales, and then number of hours we study number of study hours and marks. If we spend more hours for studying, we will end up getting more marks because we learn better and we get more marks. So this is positive correlation, where if we increase one variable, other variable will also increase. If we reduce one variable, other variable will also reduce. So this is positive correlation. We say variables deviate in the same direction, or change of value of variables are towards the same direction. That is positive correlation. So the next type is negative correlation. Here the variables deviate in the opposite direction. If two variables deviate in the opposite direction, we say that the variables are negatively correlated. So what do you mean by this? Is like I had already given the example of price and demand. When one variable's value increases, other variable's value decreases. So if price of an item increases, its demand will reduce. So that is a negative correlation. So here increase in one variable leads to a decrease in the other, and vice versa. Decrease in the first variable leads to an increase in the other. This is negative correlation. And the last type we say zero correlation. So zero correlation means two variables are not at all related. So change in one variable will not affect the change in the other variable. Two variables are not related. These are three types of correlation. Now how do we express these types and how do we measure them? So this is a simplest way of representing correlation. Here we are not interested in finding any value or finding any measure of the to the extent what these variables are related. We just want to represent it diagrammatically. So that is scatter diagram. So representing value of both these variables in the form of a diagram. So here we have to plot the points, and when we plot the points, we'll just see how it appears. Say for example, for positive correlation, if you have x and y axis, I'm just writing a random scale. Now when I plot the points, when x is 1, y is 1, when x is 1.5, y is 2. So like this, when I plot the points for different values of x. See, we are talking about statistics where we have so many values, right? Large amount of values. So if the points look like this, moving towards upper direction, okay, so basically it is moving towards upwards. So this we call it as positive correlation. Positive correlation, if I represent using scatter diagram, if I plot those points, this is how it is going to appear. Here if you observe, as we move towards as the value of x increases, y value is also increasing. So this is positive correlation. If these points form a perfect straight line like this, if I plot the points and the points are it looks like a straight line, then we say this as perfect positive correlation. It is moving towards upwards, but it forms a perfect straight line, so we call it as perfect positive correlation. And then for negative correlation, the diagram is going to look like this. When x is less, y value will be more, and as x values keeps increasing, y value is decreasing. So basically the values will be moving downwards like this. So this is called as negative correlation, and if it forms a perfect straight line, we call it as perfect negative correlation. So the values are going to look like this. If the points form a perfect straight line like this, then we say that it is a perfect negative correlation. Now this is how it is going to appear if you are plotting a graph using the values of x and y in the form of a scatter diagram. Here if you observe, we don't get any exact perfect value. There is no formulas here, there is no analysis or calculations. It's just a rough pictorial diagrammatic representation of the values that we are analyzing. Here we have something called as a correlation coefficient. Correlation coefficient is a numerical measure of to what extent the variables are related. Okay, so it is a numerical measure of relation between two variables. We usually denote Rxy to measure this correlation coefficient, and here for positive correlation always the value of R is greater than 0 and it is going to be less than 1. So R is greater than 0 and less than 1. This is for positive correlation of this type. For perfect positive correlation, R will be equal to 1, and for negative correlation, R will be greater than -1 and less than 0, and for perfect negative correlation, R is exactly -1. So basically it's easy to remember. For zero correlation, R is 0. If it is positive, it's greater than 0. If it's negative correlation, it is less than 0. If it's perfect positive correlation, it is exactly equal to 1, and perfect negative correlation is -1. You will never get values less than -1 and greater than 1. You won't get 1 point something. If you get 1 point something, means your calculation is wrong. The values will never go beyond 1 and it will not come below -1 as well. So that is the correlation coefficient. R always lies between -1 and +1. Okay, so R is 0 for zero correlation. If you represent this using scatter diagram, there won't be increasing or decreasing points like this. It will just be scattered everywhere. Okay, so fine, this is correlation coefficient. Now we'll see different measures of correlation coefficient. There are actually many measures, but important ones we'll see here under bivariate frequency distribution. That is, so we have Carr-Pearson's product moment correlation coefficient. It can be simply called as Pearson's coefficient, Pearson's R, or product moment coefficient. This is used for quantitative data, or this is used for quantitative variables. I think I have explained this in the previous video. We have quantitative and qualitative variables. Quantitative variables are those that can be measured. Say for example, the examples that we have taken here are all quantitative variables. I can measure how much I am spending and how much I am earning, and I can measure number of hours put into study and number of marks that is received, right? So basic price and demand as well. So here we can measure the variables. Measurable variables are called as quantitative variables. Those that are not measurable will be qualitative variables, which are actually is going to represent the characteristic of object or a person. So it is a characteristic which cannot be assigned perfect numerical values. Say for example, being beautiful. So what is beautiful? So there is no measure for that, right? So what is we can only say not beautiful, or moderately beautiful, or very beautiful, extremely beautiful. We can only say that. So all of you would have done some purchasing through Swiggy, Amazon, whatever. You will get a rating. You will have to give feedback. There you will have stars like this, right? There for the feeling that we have of using the app. So we have used an app and we have got a service, and because of that service we might feel happy or we might feel grateful, whatever. So for that feeling that we have, we are going to assign a numerical value. So what is that? Very unhappy, extremely unhappy, you're going to give 1 point, and very happy you're going to give 5 stars, right? So 1 star represents very unhappy, second star represents somewhat unhappy, third star represents neutral, and fourth star represents happy, and fifth star represents very happy. So all of us have used some apps which asks us feedback like this. Here being happy is a qualitative thing for which we are assigning a quantitative value, right? We are assigning a numerical value. Such a type of variables come under qualitative variables. So this Carr-Pearson's coefficient, it is used for quantitative variables. So to find this product moment correlation coefficient, we use the formula R is equal to covariance between x comma y divided by standard deviation of x into standard deviation of y. This is the formula for Karl Pearson's product moment correlation coefficient. If you remember, in one of the previous videos we have discussed formulas for standard deviation of x and standard deviation of y. For that I had given two set of formulas. Here also we are going to use those two separate sets. If you have not watched the previous video, make sure you watch it and learn how to calculate this standard deviation of x and y. So here we have two set of formula. One is with deviations and one is without deviations. So I'll give you all the three formulas in which we use deviations. So covariance x comma y is equal to sum of x minus x bar into y minus y bar. I have also told about this deviations in the previous video. What is deviation and how to calculate that? Please go through the previous one if you haven't watched it yet. Divided by n. So this is product of deviations divided by n. This is the formula for covariance of x comma y. Then standard deviation of x is equal to sum of deviation square divided by n whole root, and standard deviation of y is sum of squares of y deviations divided by n. This is with deviations. If you are not using deviations, without deviations, then covariance of x comma y is sum of xy divided by n minus mean of x into mean of y. This is the formula for covariance of x comma y. Standard deviation of x is sum of x squared by n minus mean square root of this, and standard deviation of y is sum of y square by n minus y mean square. These are two set of formula. Either use all these three or this three. Now which one to use depends on what is the type of data given. After determining each one of this, substitute in this main formula and find out the value of r. So as informed earlier, it is going to be between -1 to +1. So this is about Karl Pearson's product moment correlation coefficient. And then we have Spearman's rank correlation coefficient. Spearman's rank correlation coefficient is used for qualitative data. Like I mentioned earlier, this is going to be used for data which does not have proper numerical measures, but we are going to convert it to measures by assigning ranks. So for these qualitative data, we will be assigning ranks. Ranks are assigned for the given values. We will assign ranks for given values, and then we calculate deviations between the ranks and we find out deviation squares, and then we use a formula. I'll give the formula, and here there are variations in the questions. So if 2-3 different variables share the same rank, that is called as ties in the rank. For that the formula has a variation. So detailed variations with example problems we will see in the upcoming videos. Here I'll just give the general formula that is used for calculation of Spearman's rank correlation coefficient. This method we will use for calculating the relation between example like beauty and intelligence, say qualitative data. Here example I can write beauty and intelligence. So whether they are related or not, if yes, to what extent they are related. So here these two things, both these things are actually something which cannot be measured through a proper scale or proper way, right? We have to only assign some ranks, assign some numerical values, and then allot some ranks, and we have to score them. So the formula for calculating Spearman's rank correlation coefficient is represented using rho, and this is 1 minus 6 times summation of d square. D is deviation between the ranks and we are going to square those deviations, and that is and after squaring the deviations we will add all of them, that is summation of d square, that is multiplied with 6, and this is divided by n into n square minus 1, where n is the number of values given. So this is the formula for Spearman's rank correlation coefficient. And if the scores has a tie, if it has some values that are common, and if there is a common rank that is shared among them, then we have an alteration of this formula which can be explained with the help of a problem itself. So this is about correlation, its meaning, definition, types, and representation, diagrammatical representation of it, and what are its boundary values, and how to measure it for quantitative variables and for qualitative variables. In the next video, we'll see detailed step-by-step procedure for this with problems and solutions. If you are BCA or MCA student of IGNOU, then you can join the Telegram channel. Link to that is mentioned in the description. You can join that and you will get all the previous year's question papers with notes. See you in the next video. Bye bye.